Alright, so hi guys. So in this video, what I want to go over is this problem. So, um, first and foremost, I really struggled with this problem. And this is the type of problem that I'm not gonna lie to you guys, I hate doing these. But I did figure it out, and I am gonna show y'all exactly how to do it. These are very difficult because it requires you to know a topic from algebra that you do not see, or from pre-cal, that you do not see until like Cal 2. It is partial fraction decomposition. So I guess I will make this into a two-part video because the first part actually requires us to decompose this fraction, to split it up into two different fractions and then integrate. So I guess this first part will be kind of the algebra portion of the calculus problem. So I'm gonna go ahead and integrate this. Now there is a rule, and actually I'm gonna go ahead and do the partial fraction. Now there's a rule here that when you have the following, and let me see if I can find it. Give me 1 second, guys. Now, I am gonna, like I said, go over a rule. So, let me just type this down, guys. So, this is from the Larson textbook. I will post a link, or I will put the title to that in the description, and it is on Chegg, so I will go ahead and probably, I will go ahead and put the title to the textbook and also the edition by Ron Larson. But the rule goes like this, and if we have quadratic factors on the bottom, so this is where, we consider quadratic factors, it's going to be the following. So it says for each factor of the form, and like I said, guys, for every video that I do, I always put the rule because I always put the theorem we're using. So if you don't like that, I do apologize, but honestly, a lot of people do need to know why we're doing problems a certain way. So for each factor of the form ax squared plus bx plus c raised to some power n, and it says the partial fraction decomposition must include the following sum of n factors. And so, I'm sorry, of n fractions, excuse me. So, so here, we want to go ahead and use, the following formula, and it's going to be like this. B sub 1 x plus c sub 1 over ax squared plus bx plus c plus, and it's going to be the following, and it has b sub 2 x plus c sub 2 over the quantity ax squared plus bx plus c raised to the second power, or squared, right, plus dot 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 plus b sub n x plus c sub n over the quantity ax squared plus bx plus c raised to some power n. And so we must understand that what this means, you know, we're doing it for when there's quadratic factors. This is one of the theorems that we're using. So on the top we have ax cubed plus 13x over x squared plus 2 quantity squared. This is going to equal the following, and I am going to write it the following way. Let's see here. Hold on. So I'm gonna say, instead of b1x c1, I'm gonna just use bx plus c. And actually I'm gonna use ax, so it's the same thing, guys, if you think about it. Ax plus b over, and it's x squared plus 2 plus, and it's cx plus d. So I'm sorry, guys. Oh my god. Over x squared plus 2 quantity squared. So just know that this part is my original quadratic that is on the bottom, or my polynomial is on the bottom, that is on the bottom. Because I need to get rid of the denominator on both sides, you know, as much as I can. Obviously, on the left side, we need to get rid of the denominator completely. So what I'm going to do is I'm going to multiply by x squared plus 2 quantity squared on both sides. So if I do it to one side, I have to do it to the other side as well. Now, you need to be careful when you do this, guys, because you need to distribute that factor, or this you know, this binomial squared into the equation on the right. So we have to use distributive property. So we have 8x cubed plus 13x equals, and like I said, it's gonna be ax plus b times the quantity x squared plus 2 quantity squared over x squared plus 2 plus cx plus d times the quantity x squared plus 2 quantity squared. So I'm just doing this for those of you that don't know how to do this in your head, okay? So, and then over x squared plus 2 quantity squared. So then we're going to have the following. Obviously, if you use laws of exponents, guys, 2 minus 1, you know, when I have the following au squared over u, let the u part be the x squared plus 2 quantity squared. Okay, I just want to quickly, you know, show y'all this. This is really just going to be a times u. So, you know, the properties of exponents, when we have u squared on the top over u, we just subtract the exponents. Au to the 2 minus 1 is equal to au. So just reiterating that. Now, so that means that, you know, if I'm going to let u equal to x squared plus 2, and a is ax plus b, right? So I just want to, you know, I know I'm being very specific here, but, you know, I'm just wanting to, you know, show y'all what I'm doing. Oh, and I'm sorry. So, so here we're going to have the quantity ax plus b, and it's going to be times the quantity x squared plus 2 and then plus, and then obviously on the other one with the cx plus d, this is going to cancel out. So we're just going to have plus cx plus d, you know, like this. Okay. And so, obviously this was equal to 8x cubed plus 13x. So I'm just going to quickly. Okay, guys. Now, what we're going to do here, we are going to go ahead and use the FOIL method. So, or distribute, right? I mean, obviously, so, here we're going to go ahead and just FOIL this out. It's going to be ax cubed plus 2ax plus bx squared plus 2b is equal, I'm sorry, plus cx plus d, right? Is equal to 8x cubed plus 13x. Okay, guys. Now, here, we're going to want to put this in terms of descending exponents. So write it in terms, so write this of descending exponents. So, we have ax cubed plus bx squared plus 2ax plus cx and then plus 2b plus d. So I'm just writing it down in terms of descending exponents here. I just want to make sure I did it right. Bx squared, 2ax, ax cubed. Okay. And this is obviously equal to 8x cubed plus 13x. Okay. So this is where it gets interesting, guys. You need to write this in terms of, you need to make sure you include, on the right side, include x squared factors and constants. What I mean by this, guys, is you need to make sure that you write it in terms of descending exponents, even if the, like x squared would be 0x squared. Make sure you write it that way. So what I mean is, write this the following way. We have ax cubed plus bx squared plus 2ax plus cx plus 2b plus d equals, and it's going to be 8x cubed plus 0x squared plus 13x plus 0. So that's what I mean. Make sure you write it x cubed, x squared, x, and then the constant. Now, let's go ahead and factor the x's from each part here. So what I mean is we're going to go ahead and use, we're going to factor certain things out. If you notice, guys, there is an ax cubed here. We're just going to kind of put everything aligned here. So we have ax cubed, bx squared, and then, let's see here, 2ax, actually, hold on, it's like this, and then 2ax is this one, 2ax plus cx, because obviously that it has x's there. It's in terms of just one x. And then the 0 would be the 2b plus d. So I'm just gonna put, I'll do this color, it's fine. So, this part will be this part. Now, if you think about it, guys, this is gonna give us the following: a times x cubed plus b times x squared plus 2x plus x times the quantity a plus 2a plus c, right? And then plus 2b plus d is equal to 8x cubed plus 0x squared plus 13x plus 0. Now, again, I'm going to align each part with everything. So what I'm going to do, so the 2b plus d aligns with the 0, right? Just like we've been doing. So you kind of have to make sure you keep everything aligned. This is very difficult because you can easily mess up. You have to go very slowly. So then we have this going on. And then we have this going on here as well. So I'm just kind of aligning everything with everything. So then, if you think about it, guys, you can put every factor with equal to each other. So ax cubed can be equal to, so set up a system of equations. And we're going to solve for a, b, and c, and d. I'm sorry, a, b, c, and d. So we have ax cubed equals 8x cubed. Bx squared equals 0x squared. So just making it equal to every part here. And then, and it's going to be x times 2a plus c is equal to 13x. And then what is it? The 2b plus d equals 0. So again, I am going to color code these. So we have, like I said, this one was in yellow. This is in like baby blue or aqua. And then this is in hot pink right here. Okay, guys, and then we're doing this in orange, so the last part is in orange, okay? So just be very careful with how you do this. It is very tedious. Okay. So we have the following, and so we end up having, let's see here. So I'm just gonna solve each equation. So we have ax cubed equals 8x cubed. To solve this for a, we need to divide both sides by x cubed. So we're just gonna, and so we end up, when we do that, we end up getting a is equal to 8. So we already have one of them. I'm gonna circle that. Okay, and I'm going to put it in yellow because, like I said, okay. Now, here, we're going to go ahead and now we're going to do bx squared equals 0x squared. So, obviously, if you can clearly see that b is equal to 0 because when we divide by x squared on both sides, we get b is equal to 0. So then we have b is equal to 0. And again, I'm going to highlight that. So highlight that in this color. And then we have x times 2a plus c equals 13x. So we have the following. So we have this going on. And again, we're just going to divide both sides by x, obviously, because, you know, we have to solve for, we need to make it as an equation, right, in terms of a and c. So just going to divide both sides by x. This cancels out, and this cancels out, we end up getting 2a plus c equals 13. So I'm going to highlight that in hot pink, so right here. Okay, and then we end up, and then finally the last one, we just have 2b plus d equals 0. So that's already in terms of an equation. We don't really have to like get rid of any x's there. So we can go ahead and just put that as the last equation here. So now our system of equations is going to be in the following way. A is equal to 8, b equals 0. So a equals 8, b equals 0, 2a plus c equals 13, and 2b plus d equals 0. Now, solve the system by back substitution, really, because obviously we just have to substitute for certain values. Now, if I substitute this for a right here, I'm gonna get 2 times the quantity 8 plus c is equal to 13. We have 16 plus c. I'm sorry, 2 times the quantity 8 plus c equals 13, so then 16 plus c equals 13. We're going to go ahead and, to solve for c, subtract 16 on both sides. We end up getting the following. C is equal to negative 3. So we have, you know, again, that is another, you know, I'm circling that right there. Now let's go ahead and now use the 2b plus d is equal to 0. So substitute d into, I'm sorry, substitute b is equal to 0 into this equation. So when b is equal to 0, we end up getting 2 times the quantity 0 plus d equals 0, which is 0 plus d equals 0, which is d is equal to 0. So again, I'm going to circle that. And then, so we have a, b, and then finally, I think I still need my c value. Oh no, I have my c value. So my 4 answers are a is equal to 8, right? A equals 8. B is equal to, I think it was 0. Yeah, B equals 0. C equals negative 3. And D equals 0. So again, let me just rewrite the following partial fractions that I came up with. So we're going to go ahead and rewrite the partial fractions. Okay, guys? So let me, hold on. Let me just go ahead and do this off camera. Or actually, I'll just write it. So we end up having ax plus b, so it was 8x cubed plus 13x. Over, and it was, I'm sorry, it was over x squared plus 2 quantities squared. Is equal to, it was ax plus b plus cx plus d. So ax plus b over x squared plus 2 plus cx plus d over x squared plus 2 quantities squared. And so finally, we're just going to go ahead and just plug in the following values. So we end up having that, saying that 8x cubed plus 13x over x squared plus 2 quantities squared is equal to, and it was 8x plus 0 over x squared plus 2 plus the quantity, and it was negative 3x plus 0 over x squared plus 2 quantities squared. So all in all, as a partial fraction, thus our final answer is, I'm sorry guys, hold on, oops, is gonna be that 8x cubed plus 13x over x squared plus 2 quantities squared is equal to 8x over x squared plus 2 minus 3x over I'm sorry guys, hold on. Give me a second guys, hold on. Over minus 3x over x squared plus 2 quantities squared. And so this is our final answer for the partial fraction decomposition portion. So that is going to be it for this first part, guys. This was really long. So I really wanted to explain this in detail. It is a lot. So do not feel too bad if you feel overwhelmed. This is very difficult. It takes a lot of practice. Even for me, I found this really difficult and really long. So in the next part, I am going to go ahead and actually integrate this entire thing. So this is just the first part of, of this problem. But if anybody has any questions whatsoever, please let me know. And thank you so much for watching, guys. And with that being said, please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.